the velocity of a 500-gram particle at the point r equals 4I plus 3j minus 2k meters is v equals 5I minus 2j plus 4k meters per second. What is the angular momentum of the particle about the origin? So now we are supposed to find angular momentum, but we know that from theory, angular momentum is giving us the cross product between the displacement vector r and linear momentum. But we know that this linear momentum is giving us the mass times the velocity vector, and therefore angular momentum is giving us a cross product between the displacement vector and the mass times the velocity. So if we factorize out the mass, then angular momentum is giving us mass into bracket times the displacement vector, the cross product of the displacement vector and the velocity. Now, from the question, we're given the displacement vector as into bracket 4I plus 3j minus 2k, and then we're also given the velocity vector as this one is the velocity vector, which is into bracket 5I minus 2j plus 4k meters per second. So now let's first find what is in this bracket, which is the cross product between the displacement vector and then the velocity vector. So let's find r cross v. This is equal to, now we are doing a cross product, and anytime you do a cross product, you are supposed to get a vector. If you do a dot product of two vectors, you will get a scalar. But if you do a cross product of two vectors, you get a vector. So this will be the position vector I, then the position vector j, and then the position vector k. And let's bring our bracket down here. So now we are taking the first vector is a position vector, which is r. So sorry, these are unit vectors: unit vector I, unit vector j, and unit vector k. So the position vector r is 4I, then 3j, and then 2 minus 2k, so minus 2. And then the velocity vector, we have 5I, so 5 comes here, minus 2j, and then plus 4k, so minus 2j and then 4k. So now this is equal to, you bring the unit vector I first. Now remember that this is plus, minus, plus. This is the cofactors of the matrices. So now this will become I, then you cross out the column and then the row of the unit vector I, then you can find the 2x2 matrix, the determinant of the remaining 2x2 matrix. So that will become 3 times 4 in this case, minus into bracket minus 2 times minus 2, bracket close. Then we have minus, so minus j, then into bracket you cross the row and column of j, so below with 4 times 4, and then minus, if you, that will be 5 times minus 2, so 5 times minus 2. So let me bring the k side there, so plus, so let me cancel this, plus the unit vector k, and then we'll cross the row and column of k. If we do that, we are going to get 4 times minus 2, then minus 5 times 3, bracket close. So this is equal to I, then bracket open, 3 times 4 is 12. Then minus 2 times minus 2 is minus 4. So it becomes 12 minus 4. Bracket close. Minus j. Bracket open. 4 times 4 is 16. Then 5 times minus 2 is minus 10. Minus 10 times minus 1 becomes plus 10. Then plus k. Then 4 times minus 2 is minus 8. So we have minus 8 here. Then minus 5 times 3 becomes minus 15. So this is equal to, now 12 minus 4 is equal to 8. So we have 8i. Then 16 plus 10 is 26. So we have minus 26j. Then minus 8 minus 15 is minus 23. So we have minus 23k. So this is r cross phi. So now to find the angular momentum, remember we said angular momentum is mass times r cross phi, but the mass m was given as 500 grams. That is this. Now this 500 grams is the same as 0.5 kilograms, and therefore the angular momentum is equal to 0.5 then times 8i minus 26j then minus 23k. So this is equal to 0.5 times 8 is 4. So we have 4i. Then 0.5 times minus 26, it becomes minus 13. So minus 13j. And then 0.5 times minus 23, it becomes minus 11.5k. But the unit of angular momentum is kilograms meters per seconds. So that's the unit for angular momentum, and therefore the angular momentum is equal to 4i minus 13j minus 11.5k kilograms meters per seconds.